Okay, YouTube, Facebook, Mr. Kelly here. All right, so 2 years ago, Boomer, Carrie, stop it. 2 years ago, I sailed to Hawaii and back in my 33-foot Pearson 10M sailboat. Along with me, my good friend Cosmo took his West Sail 32 on the voyage also in his vessel, so that we had basically an escape plan or a backup vessel if one of us had a catastrophic problem. Anyway, so on the way back, what I found out was on the way over, my self-steering autopilot tiller failed. It imploded. So I had to steer probably 60% of the way to Hawaii, 24 hours a day. I had one crewmate by hand. Very hard to do. Very tough on us. Anyway, I purchased 2 more autopilot tillers, and we came home. Cosmo had this self-steering windvane. His was a Monitor brand, and by having that, you didn't have to have power, and if you lost your tiller or something, your little automatic steering thing, you had your self-steering windvane to steer the vessel to get you home. And one of the problems is on the way back we had several days, more than that, of no sun. So my solar panels couldn't keep up to charge my batteries. And so I had to start the engines, trying to keep the power up to run my tiller autopilot. If I'd have had this, a self-steering windvane, that would have eliminated a lot of electrical draw, because that was probably the biggest draw I had electrically. So anyway, I have built my own after studying these things. Now this is just a working model mock-up, but it actually works. I built it all myself. The way this works, okay, is that you set your course for your vessel and you adjust this. Say the wind this is in neutral. Say the wind is blowing this direction on the side of that, on your port side. So you adjust this to where this vane is neutral to the wind, so the wind can't affect it. It blows by like a knife slicing through butter. All right. So what happens is, if you go off course, now the vessel turns. So now the wind is hitting this tiller, this wind vane, and it pushes it over. When it pushes it over, there's a connecting rod here that I made all these goofy little things. That push this rod, which I made homemade gears, they actually work, but I will do a lot better job than that. So that rod, when it pushes over, it pushes which turns the gear. When it turns the gear, if you look down here, see how it turns the rudder? Okay, so now when it pushes over and it turns that rudder, the water hits that rudder and it pushes this arm up. When it pushes it up, there will be lines attached on both sides. The line will come over to a bar that I haven't added because it's just a mock-up. So the line will come to a bar pipe with a pulley. From that pulley, it goes up into here to another pulley. From that pulley, it goes to the vessel and to another pulley, and then runs to your tiller, right? So when it goes over, it pulls that line, which pulls that tiller to you. When it pulls that tiller to you, the boat changes course. The main rudder changes the course of the vessel and gets you back the direction you're supposed to be heading. Now, this was pushed over, remember, by the wind. But once the vessel turns and the wind becomes neutral, this thing flops back to center. When it does, it releases the pressure on that line and tightens up the other line now, and the tiller will come back to your course and hold your course. If you go the other way, same difference. when it turns, when the vessel goes off course, the wind blows the wind vane turns the rudder, the water pushes the, see how this swivels freely up here? Pushes this over, pulls the line, pulls the tiller when it puts you back towards course. When you come back to course, the wind that was pushing this now comes back to neutral and you're back on your course. So quite pleased with this. The gear cutting and the proper angle and alignment, that was a lot harder than I thought, but I did get it after 2 tries. Believe it or not, I got lucky that it actually worked. But I got it after 2. Now it needs a lot of dressing up, of course, and file work, but I'll probably make these maybe out of brass. Or may make them out of steel, or I may actually purchase a set of 90-degree gears. I did look at some, and it's the same difference. It has a little gearbox, and you just the output shafts you just would extend out to these things, and then you eliminate trying to homemade gears, and the rest of it is very simple, very simple. Here they have on these they have a big heavy weight. I just zip tied this magnet on it. What that does is it helps bring this back to center, and when it brings it back to center, it adjusts that rudder, which then the water force releases off of it and straightens your tiller out. So that's it. This swivels and you can lock it. You would have to lock it in place. I would probably do an arm. What some of them have is a this piece here comes down and they put a sprocket on it with a chain running back to another sprocket that has a rod that rotates, and on top of that they have a pulley with a line running to the boat. So from inside the boat, inside the cockpit, you wouldn't have to reach over the back of the vessel. You could just pull that line, which turns the pulley, which turns the sprocket, which turns this sprocket, and you can adjust this to your neutral wind position. But no big deal. I mean, on my vessel it would be close enough that I could just reach over and do this. The only thing I have to do is come up with a locking system, which could be as simple as one hole in this plate, multiple holes in that plate underneath that hole, and then just drop a pin in. When you get the angle you want, drop it into the closest hole. But you'd have to make your holes pretty close together to where you get the right setting to hold your course you're hitting. Okay? So anyway, very pleased with this. I'm by no means a expert welder, but I'm good enough to do this. I may make it out of stainless steel, and my welder will weld stainless steel. I just have to change the gas to my welder. And yeah, like I said, I'm very happy with this, and on my next long voyage, that'll make a big difference. I won't be using any power. You can see my wind vane. Oh, I was going to say that. So the wind vane, what we'll still have to figure out is how big to make the wind vane. So in lighter winds, you would need, theoretically, I think, a bigger wind vane, because the less wind, it's not going to push a small, maybe not be able to push that over. Now, this is aluminum, and like I said, it's a mock-up. I've seen some that are fiberglass, they look like, some with a metal rod about that size that they make a frame out of, and then they use canvas attached to it for, I guess, for weight. And then, of course, the rudder, this is tiny only because my workbench that I hung it on, I only have so much room. Obviously, I would need a bigger rudder, which will help with the force of the water to make the adjustments, to pull the lines to the tiller. So, yeah, that's it. Thank you for watching.